Great. So it's really an honor to be here to give this keynote. I'll be talking about the future of generative AI and all kinds of exciting things that we can do together with the SKT and Anthropic partnership. And since I'm the Chief Science Officer at Anthropic, I'll be focusing a lot on the research and possibilities for what we'll be able to do in the future, because I think we're expecting really, really dramatic progress that is going to be really changing the world. So there have been a lot of developments in generative AI in the last few years that Anthropic's researchers and technical people have been contributing to. And so early on, long ago in the history of generative AI, which means only 7 or 8 years ago, many of the sort of Anthropic researchers, especially Dario Amodei, our CEO, sort of realized the technology was going to make really rapid progress, and there were going to be also safety problems in bringing this technology to market. And so back in 2017, we developed this idea, reinforcement learning from human preferences, which is a way of training these fundamental AI systems to be useful and safe for human use. We also started developing a lot of our interpretability work, which I think is going to be really important going forward. Then we built some of the first sort of large language models, GPT-2 and GPT-3, and we hit upon this idea that I'll briefly touch on in a second of scaling laws in AI, which have really motivated this explosion of more and more powerful models, more and more powerful AI systems, and allow us to sort of predict that we expect AI capabilities to improve in the future. And I'll talk about what that really means. We founded Anthropic so that we could really build a company where we could put these developments, both in terms of new AI capabilities and their sort of safe use at scale, into practice. I led the team that developed Claude, our first sort of conversational AI assistant that we continue to develop. And then we developed constitutional AI, this idea that I'll talk about a bit more, that we can use AI systems to train themselves to follow a list of principles, which really makes it possible to train systems that are safe and beneficial for use in all sorts of different markets internationally, which I think is crucial for the application for telecommunications. So because I'm sort of this researcher, I'm a scientist, I have to have a couple of figures. But what these figures really show is that you can make AI systems predictably more powerful, more capable by using more data, bigger neural networks, and more computation to train them. So there are all these straight lines, and this allows us to really have faith that we'll be able to build ever more interesting, useful, capable AI systems as time goes on. And that's really been a trend that we've seen in the market. So here we have just sort of from the earliest like GPT language models, GPT-1, which could barely write a coherent sentence, out to current state-of-the-art models, we see that there was a million-fold increase, basically, in the amount of computational resources that have been used to train these systems in just the last 4 or 5 years. And these numbers are really mind-boggling. We like to say they're astronomical, because literally, if you're asked how many stars are there in the universe, it would be sort of a line on this plot, which is a little bit below the amount of computation used to train GPT-3. So these numbers are really bigger than the number of stars in the entire universe. And the other important thing here is there's like a very clear trend that as time marches on, we're using more and more computation to train more and more powerful systems. And so the question is sort of what will those systems be able to do for us and for our customers in the future? So where will this take us? And I think about this in terms of 2 different directions. So below where you'd see on this plot, there might be the first AI systems that we heard about, things like AlphaGo, that can play board games really effectively. But AlphaGo isn't very useful because it's so restricted in the generality of the environment that it can operate in. And with the advent of large language models, we first sort of had these systems that can really use text in any language very effectively, and you can converse with them. And I think one of the directions that AI systems are going to develop in over the next few years is to be able to interact in more and more general environments, from text to code to being able to use all sorts of tools like APIs, onward to multimodal models that can really understand images, sound, et cetera, and even models that could maybe pilot a robot in the real world, that can become part of the world with us. So that's one way that I think AI systems are going to develop and improve. The other direction is what's the complexity of the things you can ask these AIs to do in these increasingly general environments. So one way of thinking about that is, how long would it take a person to do some of the things that AI systems can do? And where are we at now? Well, we can ask AI systems to write long essays for us, to answer complex questions. We can ask Claude to read an entire book, summarize it, answer questions from it. So these are things that take people minutes or maybe even an hour to do. But I think that as AI systems become more capable, they'll make fewer and fewer mistakes. They'll recognize their mistakes and fix them. And we'll be able to ask AI systems to do more and more complex tasks. And that will make them more and more useful to us and to our customers. So I think these are sort of the two different ways in which I expect scaling, increasing the compute and the efficiency of these models to affect what these AI systems can do as we look into the next couple of years. And really, I don't expect this to be far away. It's really, I think a lot of this is going to come about really in the very foreseeable future. And it's very exciting. It's very daunting. One of the techniques I mentioned that we use to control and train these systems is constitutional AI. Constitutional AI is based on the idea that we can just write down a list of a few important simple principles, have AI systems experiment with the kinds of questions, when we're talking about large language models, the kind of questions they can answer, the kind of documents they can process, the kinds of tools they can use, which might be operating a smartphone or interacting with a user. We then have the system evaluate its own behavior based on this list of constitutional principles. And then we have it align itself to improve its behavior to be better behaved according to the principles we've chosen. And so this is a really flexible, fast-moving process that we can use to align systems with whatever the principles are that we need to operate under for all sorts of different users, purposes, and audiences. And so, for example, this is a way that we were able to make Claude much more dynamic, where simple systems trained just to sort of avoid problematic behavior might just refuse to answer a question, but we were able to train Claude just in the process of a few days of self-supervision to provide more interesting, nuanced, and sophisticated responses. And so I think that, why did I talk about constitutional AI, this thing that we've developed and deployed over the last year, when thinking about the future of AI systems? The reason is that I think that the general ideas underlying constitutional AI will really be able to make AI systems we develop for the partnership between Anthropic and SKT more powerful, more useful, more relevant to our users. So I think there's sort of four areas here. There's building AI systems that are more international. I think right now, Anthropic as an American company is we operate primarily in English, but I think future AIs will be vastly improved at basically all languages that are in wide use throughout the world. And I think partly this is going to come about through the application of AI itself. For example, we're already using Claude to generate training data translated into other languages for constitutional AI, so that we can teach Claude to to operate more effectively for all sorts of different users and audiences. A second thing is that we're now using these same ideas to make AI more reliable. It's really important to make AI systems that are honest, that are factually accurate, and they're sort of faithful to the purpose that their creators ask them to follow. And so I think we're going to be able to use these techniques to build smarter AI systems that supervise themselves and make AI more reliable. A third area that I think will be really, really important for the partnership is making AI systems that can effectively use tools. So, for example, like if we want an AI system to operate a smartphone, that's going to be possible by integrating AI systems with the kind of tools that control functionality. And furthermore, these systems can use things like internet search, web browsing in order to find the information they need, or they can look up information in proprietary data sets that we provide them with in order to sort of operate effectively. And finally, I think that also, I mean, all of these things are really very near future. AI systems will be able to understand all sorts of different modalities of interaction. So for example, they might be able to understand what a user sees when they look at their phone. Also, they might be able to use cameras to understand the world around us and make our technology more useful and more essential to our users, opening up all kinds of different use cases. So I think these are the directions that I think we're headed in really the very near future. And it's going to be really, really exciting to build together to enable all sorts of different novel use cases from generative AI. So I wanted to leave time for questions. Thank you again. It's really an honor to be here. I'll turn it over to you.